Let us start looking at the topic algebra. Now, in this video, we're going to look at the variable and then the fact that sometimes you read or hear about an algebraic expression and then an equation, and probably you hear about the identity as well. We're going to look at the differences between those three things. Now, the variable, what is a variable? Is really a symbol, usually a letter. Sometimes it's an English letter, sometimes a Greek letter, as used to represent numbers. So you can substitute a number for that letter. A popular letter to use when it comes to variables is x. So you say something like x squared. Here you can represent a number such as whenever you have x is 1, you say 1 squared. Whenever x is 2, you say 2 squared, and so on. For example, in the formula y is equal to x squared. When y is equal to 1, right? Or not when y is equal to 1, when x is equal to 1, then y is equal to x squared, which is 1 squared. When x is equal to 2, then y is 2 squared, which is 4, and so on and so forth. So basically, as you saw a while ago, I was changing the numbers. X and y are variables here because at one point x was 1 and y was 1. At another point x was 2 and y was 4. So they vary. Right? These numbers varied. So the symbol used to represent it, you call it a variable. It means it can change. To vary means it can change. Alright, so that's what we call a variable there. Now let's look at this other thing, the expression, equation, and the identity. Basically, when you talk about an expression, it's like you're saying you're expressing yourself, and you write down a mathematical or algebraic expression such as 2x plus 5. That is an expression. Right? It's a statement, a mathematical statement. Now, that being an expression, suppose I want an example of an equation. I could say 2x plus 5 is equal to 17. This is an equation. Now notice this part, EQUA. This is A. This is part of the word EQUAL, equal. The equation is saying that you have an expression is equal to another expression. So you have equa. And what you have in the equation that you don't have the expression is the equal sign. The equal sign, alright? That sign right there. So the expression does not have an equal sign. So in the expression, no equal sign. And in the equation, equate, equal, it must have an equal sign. Expression, no equal sign. The equation has an equal sign. Alright? So that's the basic difference between the expression and the equation. The expression, it does not have an equal sign. The equation is saying that this expression on the left is equal to the expression on the right. On the left here we have 2x plus 5. On the right we have 17. Just write 17 is just a number, but can consider it as an expression. Alright? It doesn't have a variable in it, but you say the left is equal to the right. What you have on the left is equal to what you have on the right. Or what you have on the right is equal to what you have on the left. But you know, we read from left to right, so we're going in this direction. But anyway, the other thing we want to look at is what is called the identity. You probably have not used the term very much before, but what we want to do is look at the difference between the equation and the identity. Alright? Now, as an identity, let me see, I could say, for example, 2 plus x squared. 3 strokes mean is identical to 2 plus x multiplied by x. Now, what's the difference between this and the equation? Let's see. Let me erase some of these things first and get a little more space. I didn't really want to erase equation, but let's erase it anyway. We won't be talking about the expression in the remaining part of the video, so let's just erase that. This is our equation. We said 2x plus 5 equals 17. Now the question is, which number could you put here to satisfy this equation? Let's see. We could solve this, but we're not going to solve it today. If you say you put 6 there, then you would say 2 times 6 plus 5 equals 2, 6, 12, and 5, 17. I knew that that was so before. Alright? So 2 times 6 plus 5 is equal to 17. Suppose I try 7. 2 times 7 plus 5 equals 2, 7, 14. 16, 17, 18, 19. Is not equal to 17. That couldn't work. If I try 5, 2 by 5 plus 5, is that 17? Remember, I'm saying 2 times x plus 5 is 17. I try 5 for x. Is that 17? Let's see. 2 by 5 is 10, plus 5 is 15, not 17, so that wouldn't work either. I cannot use 5 and I cannot use 7. Seems as if the only number I can use is 6. Right? Let's put in another equation before we go back to the identity. Suppose we say 3 x squared is equal to, let me see now, 75. By the way, this is what would be called a quadratic equation, but we'll come to that later on. And it's quadratic because you have the x squared, the variable squared. But for the purpose of this video, we just see what we could put here to make this work. Suppose we put 5 for x. Try 5. Would it work? Let me see. 3 times 5 squared is equal to, no, 5 is 25. 25 by 3 is 75. So 5 will work. Now let's try negative 5. I'm going to put negative 5 in there. Alright, this might seem to be a new idea to you if you haven't done it before, but you'll understand this even better a little later on. But let's try negative 5. 3 times, because 3x squared means 3 multiplied by x squared. You can put the multiply, but you don't really need to. 3 times 3 multiplied by x squared. 3 multiplied by negative 5 squared. Negative 5 squared is equal to, is it 75? Let's see. Negative 5 squared is the same, 25, you know. So 3 times 25 gives you 75. So negative 5 works. Good. So 5 works in it and negative 5 works in it. Let's try another number. Let's try 6. Will 6 work? Let's see. 3 multiplied by 6 squared is equal to, is it 75? 6 squared is 36. What is 36 by 3? 36 multiplied by 3. 3 6 is 18. Bring down the 8. Carry 1 3. 3 is 9 and 1 10. No, it's not 75. So these two numbers work. I know that other numbers will not work. So that's with the equation. You have some equations in which only one number will satisfy the equation. In this equation that we looked at, the 2x plus 5, only one number will satisfy it, and it's 6. Here, in this case, two numbers will satisfy this equation. 5 and negative 5, no other number. Alright, let's look at the identity now. Let's put in a 3 for x. 2 plus 3 squared. 3 strokes for identical to 2 plus x by x means 3 by 3, because we're saying we're putting 3 for x, 3 times 3. Does it work? Let's see now. On the left, 3 squared is 9. 9 plus 2, 11. 11. Let's look at the right hand side now. We're going to put at the right hand side over here. 3 by 3 is 9. 9 and 2, 11. Oh, it does work. Alright, let's try another number. We tried 3 a while ago. Let's try 4. 2 plus 4 squared. 2 plus 4 squared. Let me write my square a little bigger. Is identical to 2 plus 4 times 4. Let's see. Over here, 4 squared is 16. 16 plus 2 is 18. Identical to over here, 4 times 4 is 16. 16 plus 2, 18. Oh, so it does work for two numbers so far. Let's try another number. Suppose we try 5. 2 plus, let's put in, substitute 5 for x. When I say we put in 5 for x, what we're doing is really substituting, right? Because x is the variable, and we can put in different numbers that x represents. That means we substitute. So remember, another word for putting in place of is to substitute. It's like in a football match when a player is injured and can't play anymore. Someone on the bench comes in to substitute for them. So we substitute to replace them. We replace x with 5. We substitute x with 5. 2 plus 5 squared is identical to 2 plus 5 by 5. Let's see. 5 squared is 25. 25 plus 2 is 27. And this, let's see on the right hand side how it works out. 5 by 5 is 25. 25 plus 2, same 27. Well, I know here that any number you put any number you substitute for x will always satisfy this identity. So, in this case, the difference between the equation and the identity is that only a limited set of numbers will satisfy the equation, while an unlimited set of numbers, any number you put in any number you substitute in the identity will satisfy the identity. Alright? But anyway, for now, we'll deal mostly with expression and equation. Those are a lot more popular than identities. Alright? So we'll continue looking at algebra in the next video, so I will see you then.